Hello and welcome back to this course on Kubernetes for beginners. I am Ganesh Vilrajan from ethernetresearch.com. This is the first video in our lecture. If you're already familiar with Docker containers and virtual machines, you can skip this video and then go straight to the section on Kubernetes. However, if you wanted to learn the basics of virtual machines and Docker containers, then I would recommend you to go through this video. What is a virtual machine? A virtual machine is nothing but an operating system run on top of another operating system using a piece of software called hypervisor. The guest OS thinks that it is actually running on the physical hardware, but in reality it is not. The hypervisor simulates the hardware such as CPU, memory for the virtual machine. Here are some of the examples of the hypervisors: VMware ESX, VMware Player, Oracle VirtualBox, and Microsoft Hyper-V. If you look at the stack on the right hand side, we have the physical infrastructure at the bottom, and then on top of it we have the host OS operating system running, and then we have installed the hypervisor on top of the host operating system, and on top of the hypervisor we run the virtual machines. We could run many instances of the virtual machines on a single machine. Virtual machine example: do you know that you could actually run a Ubuntu Linux on top of your Windows laptop? This is how you can do that. First, you need to install an hypervisor on your Windows laptop, such as Oracle VirtualBox or VMware vPlayer. And then on top of it, you need to download and install the Ubuntu Linux. In this case, we have the laptop as the physical machine, and then we have the Windows machine acting as the host OS, and the hypervisor is the VirtualBox. The Ubuntu is called the guest OS or the virtual machine. What is a container? A container is nothing but a virtual machine minus the kernel minus unwanted libraries and binaries that are usually shipped in an operating system. So effectively speaking, a container is nothing but a normal operating system without the kernel and the unwanted libraries and binaries. So a container contains just the application and the application dependencies plus the bare minimal libraries and binaries that are required to run the container. Here are some of the container hypervisors: Docker Engine, CoreOS Rocket, and Canonical LXC LXT. If you look at the stack of the container on the left hand side, we have the physical infrastructure or the hardware, and on top of it we have the operating system or the host operating system running on top of the physical infrastructure, and we have installed the Docker Engine, which is the container hypervisor in this case, and on top of the Docker Engine, the Docker containers, applications that are containerized as Docker containers are running on them. So we have a green application, orange application, and a red application, each running within its own Docker container. So we have 3 Docker containers in this case. What are containers? Containers are nothing but a group of processes running in a virtualized or isolated environment called containers. The isolated or the virtual environment inside a container is provided by some of the Linux kernel virtualization primitives such as chroot, namespace, cgroups. So you cannot run a container on all operating systems. Only those operating system or the host operating system which has the container features could only run containers. So you cannot run a Docker container on a Windows XP because Windows XP may lack some of the container features. Docker containers. Docker container is the most popular version of the container engine. Its alternatives are CoreOS Rocket and Canonical LXC and LXT. Almost 90 to 95% of the market actually uses Docker containers, while the rest of the market uses the other alternatives such as CoreOS Rocket or Canonical LXC, LXD for some specific use cases. What is Docker Engine? Docker Engine is actually the Docker runtime required to run Docker containers. And this is something similar to Java runtime environment that is required to run Java applications. What is a Docker Hub? Docker Hub is an online repository or a registry to store Docker images. Most of the popular images are already containerized by Docker and are available as Docker containers to download and run. In this picture, we are looking actually at a public official Docker repository that's available for anyone to download. So we see the Nginx Docker container, Alpine Linux Docker container. We also see BusyBox, HTTP Apache web server, and the Redis database. These are available as Docker containers and anyone can download them. Benefits of Docker container. The biggest benefit is actually the isolation. You could potentially package the application and all its dependencies inside a Docker container. And once you do that, anybody can actually download the image and then run it without having to install any of the dependencies. For example, if you have a Java application and if you package the Java application along with the Java runtime on a particular version, and then you test that particular Docker container, and if it works for all use cases, then you can actually ship that particular Docker container so that the customer doesn't have to worry about which version of Java should I have on my machine to run this Docker container or to run your application, Java application. So that's how the Docker containers have simplified the job of packaging and shipping the applications. Once you have a Docker container, you could run them anywhere and then it will run just fine. You could run it on your laptop, you could run it on your lab server, you could run it in public cloud, private cloud, it doesn't matter. It will work fine and it will behave the same as long as Docker runtime is installed on all these machines. So I would compare a virtual machine to Elephant, which is huge in size and it moves slowly. It takes time to do certain things, versus containers comparable to Cheetah, which is very lean and efficient. It runs fast. So this is just to give you an idea of what a virtual machine is and how a container behaves and looks like. Here in this picture we have a stack of virtual machines on the left hand side and the stack of containers, Docker containers, on the right hand side. Some of the big differences actually, on the left hand side we have the hypervisor to run the virtual machine, and on the right hand side we have the container hypervisor, which is the Docker engine. And then the second difference is, if you look at it, the virtual machines have something called the guest OS or the kernel, but the containers don't have any of that. It just has the application and the binaries and dependencies that are required to run the container or your application. Containers actually use the kernel of the underlying host operating system for any system related function call. Say for example, if the application wants to access a disk, then it will call some open function or read function, write function. All those get translated into the kernel function calls of the underlying host operating system. Whereas in the case of virtual machine, if an application calls a function that accesses the disk or some memory, then everything is provided by the guest operating system itself, so everything is dealt locally. But whereas in the case of containers, the Docker engine or the container hypervisor would actually translate the calls from the application to the host operating system. So that's the only big difference between virtual machine and containers. And here are some of the other differences. Virtual machines are usually huge in size, in gigabytes, have a kernel, have an unwanted libraries, binaries, and utilities. It takes or consumes more CPU and more memory. It takes more time to boot up, whereas containers, on the other hand, are small in size, in megabytes, have no kernel or guest operating system, It contains only the bare minimal libraries, binaries, and utilities. It's lightweight and fast. It takes less CPU and memory, and it boots up fast. Because containers are lightweight and fast, we could potentially run thousands of containers in a single server. And if you have few hundred or few thousand servers in your private cloud, then you could potentially run thousands and thousands of containers between all these servers. Now imagine, how would you manage all these hundreds or thousands of servers that run thousands of containers, right? So it's huge number. How are you going to manage all these things? How are you going to scale up or scale down your containers? How do you distribute the load between the servers? How do you track the server utilization? How are you going to roll out new software updates? How are you going to roll back the software update if there is any problem with the update? You always do that, right? So if there is any problem with upgrade, then you basically go back to your old version that was working just fine. So how are you going to do in such a large scale environment? How do you maintain a server? How do you pull down a server and then maintain the server and then bring it back up and then put it back into the cluster? How do you handle server failures that happen just in an ad hoc manner? You don't even plan for it. So how do you manage the load when a server goes down? The answer to all these questions lies in Kubernetes. Thank you so much for watching this video, and in the next few videos we'll cover Docker containers and microservices architecture, and once we cover the basics we'll jump straight into Kubernetes and we'll do plenty of demos on Kubernetes. Thank you.